Hello, welcome to this week's Coventry University Geography webinar series. We're on time, all working nicely this week. Hope everyone's okay. I'm aware it's half term for some, so thank you all to those that are still joining us as well, so thank you very much. Just a couple of quick notes, really. Just a reminder that all of the previous webinars are available for you to stream. So they're all available on the Coventry University YouTube channel that you can find this link on. So please feel free to have a look at some of the past ones. You've got a talk from Dr. Matt Blackett on cascading hazards. You've got a talk from Dr. Alex Hasty, who's looking at place and the role of EastEnders. Myself on water and hydrological cycle. And also from Dr. Jay Catterson last week, looking at consumption and population in the work and urbanisation. So please feel free to have a look back and watch some of those as well. But this week, I am pleased to introduce my fantastic colleague, Dr. Charlie Hood-Butler, who is the course director for Geography and Natural Hazards at Coventry University. And she actually did her undergraduate with myself and PhD alongside me pretty much as well. Her PhD, or she can talk about it a lot better, but her PhD was titled Evaluating the Effect of Large Magnitude Earthquakes on Thermal Volcanic Activity. So looking at the interlinks between earthquakes and volcanoes. But today she's going to talk about the geospatial side of things and the GIS work that can be done. And to be honest, I think it's probably better for Charlie to explain it more than me. So I think without further ado, I'm going to hand over to Charlie. Cheers, Charlie.
Thank you, Craig. Hello and welcome to this week's webinar series. We're going to be focusing, as Craig said, this week on geospatial technologies and the possibilities of geoinformation. So before we get started, there is a Mentimeter opportunity for you to ask questions during the talk today. So as we're going along, if you have any questions, please feel free to add them to the link. I will show these slides again later, just at the end. So if you want to add any more questions once we've finished the talk, you can do so. So you can either add them as you go or at the end of the webinar today. So a little bit about me then before we start. As Craig said, I did my undergraduate, my master's and my PhD at Coventry. Myself and Craig did it alongside each other. But I've also had a number of other experiences, and I kind of have two hats in my role here at Coventry. One hat is in terms of geospatial technologies, remote sensing and GIS, and the other is specifically looking at natural hazards, but how we can use GIS and remote sensing to inform natural hazards. So as part of that, I've done a short-term fellowship at the University of Hawaii. That was looking specifically at volcanic activity and using data sets that are managed by the University of Hawaii. I also have industry experience as a remote sensing and GIS consultant in the UK. So this is much broader in the sense of not necessarily focusing on natural hazards, as we don't get many volcanoes in the UK. So my industry experience very much looked at using geospatial technologies in industry, agriculture and in local government, for example. And finally, I'm the course director for the Geography and Natural Hazards course in my role at Coventry, as well as my lecturing role. If you want to obviously learn a little bit more about what I do in terms of my research and my interests, I have a Twitter account, so feel free to follow me on there. But as I said, I've kind of got two hats. I've got that remote sensing hat and I've got the natural hazards hat. Today we're going to focus on more of that remote sensing, geospatial technologies and GIS side of things. And what we're going to do to start off with is start to explore what we mean really by geospatial technologies. So depending on your current A-level and your current kind of curriculum, you might have done a little bit on geospatial technologies. You might have done some things in terms of ArcGIS or Esri, but some of you might not have even come across geospatial technologies, or what I mean by that term. So it can be very new to students, particularly when you start in your undergraduate, if you were to be interested in a degree in geography, about what do we mean by geospatial and what do we mean by geospatial technologies. So we're going to start to have a look at that, discover that during the session today. We're also going to have a look at why there has been almost this explosion or data explosion in geospatial technologies in the last decade or so. So we've got increasing availability of data, spatial data or location-based information. So we're going to understand and explore really what we mean by location-based information, but why it is that this area in terms of geospatial technology is really starting to expand and quite rapidly expand as well. Finally, I'm going to hopefully give you an insight into the applications, how we in our research, but also in the wider scope of geographical research, use or how we use geospatial technologies, and think about that possibilities in terms of future possibilities, or how we might even begin to use and utilize this information a lot more. So to start off with then, as I said, some of you might have come across geospatial technologies before. Some of you might not have necessarily come across the term or even explored GIS or remote sensing. So what we mean in terms of geospatial technologies, it's quite a wide umbrella term, I would say. It's data in itself that has a spatial aspect to that. So it's a relative to a location, a place on our Earth's surface. But it involves data, it involves techniques, and it involves software. So it really depends on what you're doing and the area in which the geospatial technology that you are focusing on. What's important though with that is that all of that data, as I said, has a spatial component and a spatial element. In terms of the techniques, you all probably have a smartphone, or you have at least have got some form of digital technology where you look at location-based information. That most of the time is related to a GPS coordinate like a longitude, latitude. And it's techniques such as that allows us to get this spatial or geographic component to our information and to our data. What happens though is that once we know the location on our Earth's surface, and once we have these points and we have the attribute information that's associated with them, is that we can do a lot more with that data. We can begin to analyze it, we can begin to ask questions, we can begin to look for patterns and trends in that data. And that really then begins to extend out into applications, techniques such as GIS, Geographical Information Systems, and remote sensing, which is our ability to look at our Earth's surface from afar or remotely. And there are softwares that you might have come across before. I'm sure that all of you have used Google Earth or Google Maps before, if not Bing Maps or Apple Maps, something equivalent. But there are also specially built software packages such as Esri ArcGIS or ArcMap that some of you might have used as part of your A-levels, but other software as well that allow us to look at that data. And what we're going to do today is start to break these down in terms of that umbrella term. What do we mean by geospatial technologies? What do we mean by geospatial? But how can we use that, or how has it been used so far in the technological developments that we're seeing over the last decade or so? So what is really powerful then about our geospatial technologies, our geospatial information, is that we can analyze data based on space. And that allows us to begin to solve problems, begin to make decisions, and to begin to interrogate this information a lot more deeply than we might have been able to do if it was in an Excel spreadsheet, for example. So that can relate to anything such as physical processes, so rainfall data, location-based information on flooding, or right through to more social and policy information such as health, census data, and even indices of deprivation, for example. So the application of GIS or geospatial technologies and remote sensing is quite broad in its reach. It can go right from very social and human geography areas of research right into physical geography and even beyond. And we're seeing that utility beyond just geographical research in industry today. So looking at a few examples and beginning to think then in terms of our geospatial technologies, there are things that you, as I said, might have come across and things that might be a little bit more new to you. So in the last few years, particularly, we've seen the increased interest and use of drones. You might have remembered a year or so ago now that there were incidents of drones being flown near airports, and the airports and flights had to be cancelled because of that. So we're seeing the increase in our availability of data, or the availability or an ability to collect that data. Other information you might have looked at before, areas that you might have focused on, Google Earth and Google Maps, looking at even historic change through Google Earth, being able to see how an area has developed, right into things like Google Street View, looking at your street where you live from what effectively is a car, a picture from a car, to see how that has changed over time. But there are new areas of geospatial technologies that perhaps you haven't explored before. So things like satellite information. When you're looking at Google Earth, we have a combination of satellite information and aerial information, so information that's been collected by planes. But satellite information, particularly for geographers and geographical research, is really important. It gives us information for broad areas, so we can get, for some satellites even, information for the same point on our Earth 4 times a day, and that information can be collected for the majority of the Earth's surface as well. Into other examples such as GPS or geocoding, knowing our location on our Earth's surface. Traditionally, they would be part of a GPS receiver, a handheld unit. But if any of you have got a smartphone or have access to a smartphone, you will see that you now have that information to pick up your longitude, latitude location, your GPS location, using just your phone. We have increasing availability of what we call GPS receivers. Looking at our two other images then, our examples on here, are much more map-based or information-based. And this is using what we call a geographical information system to begin to spatially represent our information, our attribute information on a map or within a 3D surface. So we've got the ability to look at that from county level or even local authority level to map data. And you would be seeing examples like this at the moment through COVID reporting in the news, when we're seeing where there are high cases of infections or high cases of or new infections, and we can see this mapped and spatially represented on a map. So we're seeing the use of these geospatial technologies in a broad spectrum of areas, but we're seeing this increased utility of geospatial information in our everyday lives. So what's becoming important, particularly at your age in terms of young geographers or students that are interested in geographical issues or environmental issues, is how we begin to use this technology, how we begin to use it to facilitate spatial analysis and trends and understanding data in a little bit of a different way. And that's where it becomes important in our geospatial technologies, our spatial information. Where is something happening? Why is it happening at that specific location? And what is the mode that is happening? So spatial information in its basic form is information that's relative to a point on our Earth's surface. It's information about that specific location, whether that's a point, a line like a road, or a polygon, like a house or a housing estate or a neighbourhood, for example. What's common though, and is increasingly available, is that spatial location, that point on a map, that GPS location, has additional information attributed to it. We call it attribute information. But that could be information on how many people live in a town. It could be the demographic of that people, their perceived health even. It can be information on the course of a river, the roads and the road network in which a road is connected to. But all of that information that's contained within our spatial data set, our spatial information, gives us additional information, allows us to begin querying and understanding that data in a lot more detail. And what's happening with increasing technologies, with increasing availability of information, with us being connected to our world much more easily through internet and through information, is that the availability of spatial information is increasing. Most data, or almost all of the data that we're using now, has some kind of spatial element to it. With that comes the need to be able to understand and analyse that data. So our increasing access to technology, whether that is hardware like your phone, or the software that we can use to analyse that information, has accelerated the use of that spatial information. It's accelerated the use of geospatial technologies. And what we're seeing is that governments, and I'll touch on this later, governments are increasingly realising the utility and the need to use this information. NGOs and organisations are increasingly using spatial information. And we as the general public, as users of digital media, as users of smartphones, are contributing to that increased availability of information as well. So looking at examples of spatial information then, there are a number of things that you probably don't even realise which or contains spatial information. So if we look at a few examples here, most of you have either got a Twitter, a Facebook, or an Instagram account. But what's happening is that we can begin to map that engagement through a social media platform, to map your engagement and understand the spatial distribution of that information. So our two examples here, Twitter, for example, and looking at where are the majority of a person or an individual's followers, where are they seeing increased engagement from a different kind of audience and a different user base. The other example here is within Instagram, but what's interesting here is that as you're taking a photo on your phone, whether you're traveling, not that we can travel very much at the moment, but if you take a photo with your phone, we've always got a location attributed to that information. Every time you take an image, your phone is recording whereabouts have you taken that image. So I'm not sure if you've ever looked at it, but if you go into your album, in your photo album, for me on my phone, I can go in and I can see that I can have a map of all the locations where I have taken pictures, images previously using my phone. So it's becoming very powerful. The ability to know where we are when we have taken that photo, the ability to know where it is that people are engaging with us in terms of our media presence, and where we are engaging with people through social media as well. Some more geographical examples. We've got an example here from Chicago, and this is mapped through an online system, ArcGIS Online, but looking at poverty and the education. So can we associate the level of education and school education with poverty within Chicago itself? Other examples, we've got the distribution, a little bit different in its appearance here. in terms of almost a 3D representation of spatial information. So we're almost representing a graph but on a map in terms of engagement from a UK perspective. And we can see here that we're seeing very high population areas such as London, where we're seeing almost that increased information. And going back, something that we perhaps have used quite commonly before we even knew that it was necessarily spatial information or realised the power of this information spatially is something like an underground or a tube map or a transport map at least. When we start, well, particularly when I was younger, we used to look at these maps to work out how to get from A to B. That's now transformed, and you can use your phone or your smartphone device to actually say, I want to go from here to here, and your phone can work this out for you to understand where it is that you want to go and what is the quickest route. So it's not necessarily the most direct route anymore, but what is the quickest route that you get from A to B. And that's useful in terms of spatial information, but it's also useful in terms of the analysis of that location-based information. So thinking about this then, we need to think about where we can get location-based information from. And I've mentioned a few already, such as longitude, latitudes, but what we have orbiting our Earth at this moment in time is a global navigation system. It's satellite-based information, and we can connect with satellites that are able then to calculate our position on the Earth's surface. We have to have a minimum of 3, but by increasing our availability or our access and connection with satellites, we can increase the precision of our information. And with that, we can understand where we are more accurately on our Earth's surface. So satellite navigation in your car or your parents' cars, for example, phones and even smartwatches now are all GPS receivers that are constantly pinging back to satellite information or satellites to understand whereabouts on our Earth are we. With that, that gives us information about where we are through coordinates, so geographical coordinates. And most commonly, we refer to them as longitude, latitudes. There are different systems that allow us coordinates or allow us to calculate coordinates relative to our position though. So some of you might have used ordnance survey maps before and used the grid cells within ordnance surveys to work out your location. Other examples is when we have letters or mail coming through to the post, whether we've got an address and a postcode on that. And more recently, an application that you can download on your phone is our What 3 Words. So in terms of on our location, on our Earth's surface, a unique combination of 3 words to identify where we are on the Earth's surface. So rather than numerical information such as longitude, latitudes, the use of words to pinpoint our geographic location. So that's very much our spatial information, how we can collect location-based information. And what we're going to do now is start to think about how we can begin to use that. So I've mentioned a few terms such as GIS and remote sensing. Some of them might be more familiar to you, some of them might be less familiar to you. But what I want to do with this is begin to think about how we as geographers are actually beginning to use this spatial information and the applications that we can do, we can explore within this area of geography. So the first one, which is perhaps the one that you might be a little bit more familiar with, is GIS, so Geographical Information Systems. And GIS is the way that we begin to manage and collate that information into one source. I very much think of it as a geographical problem solving tool. So if you've used Excel, for example, before, you would have accessed Excel, loaded data into Excel, and that would have come up as a table, and you would be able to look at that data and begin to think about what that data means. What we have with GIS is the ability to use that tabulated information, if it's associated with a spatial reference, to begin to present that as a map, to organise it, present it, and to begin to analyse it as well as a map. And that information can be quite varied. Here in the example, I've produced some data, or I've visualised some data for Brazil. I've produced a choropath map that shows us with the deeper colours representing a higher number of population. Overlaid on that is the road network within Brazil. So we can see that, for example, in this case, our road network is higher. There's a denser road network where we've got higher population within Brazil. But there are other ways that we can use this data. We can think of things like health and crime and floods, even volcanoes. And those are very geographical issues. But more generally, we can think about using this information and these applications of GIS to look at things like restaurant reviews. What restaurant is within 5 miles of me that has a 5-star review, or a Michelin star even? Other examples of how that's going to, or how that is being used, is through planning. So supermarkets, for example, they will use information to plan where to place their next supermarket or their next local shop. They can even plan from demographics of that data, so understanding the people that live within close proximity of that point, what type of product they would like to see in their shop, from consumer behaviour, from your buying habits, understand what it is that we might want to place and market and sell in those shops. So for me, and how we can begin to use GIS as a system, it is very much a spatial problem solving tool, taking information in a spatial format and thinking about that in terms of analysing the trends and the information that is contained within there. If we look at the sources of information, then this is already what I've mentioned. Sources such as GPS, field data collection using a GPS receiver, or even obtaining this information from other sources. So the government through census data, Digimap, which contains OS or Ordnance Survey data, Environment Agency, and even more international sources such as the USGS and the European Space Agency. What we do with that information, though, once we've been able to collect it, whether it's through our own digitisation of information or through online sources, is we can solve problems. We can begin to uncover information. And that's through identifying problems, monitoring change, responding to issues, driving that decision and making those decisions. If we look at it in another sense, then what we can do with geospatial technologies, as well as driving our decisions, looking at information spatially, we can begin to observe our Earth's surface. And that is done through something called remote sensing. And remote sensing allows us to observe remotely, without being at that point on the Earth's surface, the physical characteristics of the Earth. This image in particular is one of my favourites. It's one of the earliest forms of remote sensing. Small cameras launched on pigeons that are flown over areas, and we collect images of those areas. So remote sensing has since advanced since our early days of mounting cameras on pigeons, and we can now collect information by sensors. But these sensors are quite advanced. They do provide an image like a camera would, but that image contains information. We can break down the information that's contained within this image to understand what's happening at our Earth's surface. And that's based on how we detect the information. Most sensors use energy and detect the energy that's reflected off our Earth's surface. So going back into science now and thinking about reflection and refraction. But the energy that's reflected off our Earth's surface allows us to illuminate and to see features. In our example here, this is the sun, but we do have sensors where we can collect information that isn't using the energy from the sun, and that's things like radar, where we can look at the height of a feature. With this though, our remote sensing gives us information. So our remote sensing is kind of twofold here. It's a source of data, it's a source of information, but it's also a technique, and it's a geospatial application. The information acquired normally is what we see as an image, but has information sitting behind it, has numerical information for each portion or each point on our Earth's surface that sits behind that. What we can do is analyze that information through spatial analysis, through satellite image interpretation, to extract that information, to make it useful. And I'll show you some examples of that in a moment. So there are different ways that we can collect that data. We've got satellite imagery, sensors that are on board satellites that are orbiting our Earth. We've got aerial imagery, so planes traditionally is one of the most common forms of remote sensing. And more recently, we've had drones or UAV information and UAV data or capabilities. What we have with this is that we can collect different resolutions of our data. Our satellite data can get us to perhaps meter scale information, whereas our drone data, we can get down to centimeter scale. We can pick out individual flowers, for example, at the Earth's surface. But with the different capabilities of how much information we can see on the Earth's surface, there are constraints with what information we can collect. Our satellites, as they're orbiting our Earth, mean that we can collect information globally. Some satellites collected the information globally every 16 days. Some satellites can orbit our Earth in one day. With drone data, though, it's a lot more site specific, and it means that actually we can't survey large areas. We have constraints of where we can collect information from. So with a drone, we might be able to collect information for one field, for example, whereas with satellite information, we could collect the similar information, not as good accuracy in terms of how much we can see, but at a national or even regional scale. So sources of remotely sensed data are quite important. And it's what you guys, in terms of looking at Google Earth or Google Maps, are probably quite used to seeing. You're quite used to seeing information or imagery that is remote. So it looks, or it's a bird's eye view of the Earth's surface. Most commonly, that is probably through aerial imagery or satellite imagery when we access it through Google Maps or through Google Earth. But what we can do with that information once we contain the information or can obtain the information that sits behind it is quite important, particularly in our geospatial application. So if we think of this then, it's our bird's eye view, it's our view from above. It allows us to see information. It allows us to collect perhaps more descriptive information, but also more numerical or informative information. So our first example was just a picture that we can interpret, whereas this example here allows us to see areas that have been burnt and been affected by wildfires in a region during a summer wildfire event. We can even use information such as radar information to collect information on weather patterns and the progression of weather patterns. So hurricane development, for example, picking out far out in the ocean where a hurricane might be starting to develop through the temperatures and the sea surface temperatures and this atmospheric development. And we can then track that development and the movement of hurricanes and typhoons as it is as they were about to hit land. And our final example, which is really a great example because it's taking away from that image that you are used to seeing, it's turning the information from a satellite image into different information, is how healthy or unhealthy is the vegetation in a specific area. So this is for Kenya, and it's looking at how healthy, in this case, our more green to blue colours, how healthy is the vegetation in Kenya. And we can see that our western portions of Kenya are appearing to be more healthy than perhaps our northwestern portions of Kenya. So we can either use that satellite information, the image, interpreting the image and the changes within that image. But what we can also do with geospatial technologies is break that down, use the numbers that sit behind that, the information that sits behind that to work out really quite important information, in this case at a regional or a kind of national scale, about how healthy, in this case, a piece of vegetation or the vegetation is. So what we've done so far is start to think about the geospatial technologies, the technology itself, the GIS and the remote sensing, so the technologies and the approaches. What I want to do with you, as I'm aware that as kind of your kind of development, is you perhaps haven't been able to explore this area in as much detail as you have been able to do other areas of geography and the themes within geography, is start to have a look at some examples of how we use geospatial technologies and how we apply it in the real world. So starting to think about this from a GIS perspective, GIS is our spatial information. It's information that is available on a map. And something that is available that all of you have access to, and you're able to even go and edit this information, is OpenStreetMap. And OpenStreetMap's a really powerful tool. It's what we term an open source tool, which means that we can edit and we can add features and digitize features along our Earth's surface. So for example, if there's a new housing estate that's been developed nearby, and there's been a new road built that's been built to access that new housing development, you yourself can go and edit and digitize that feature. In this example, what we've got here is that one of our colleagues has been able to actually begin to map the development and changes in infrastructure at an international scale. So one of our field trips as part of our courses at geography is we go to somewhere called the Gambia. And within the Gambia, we visit a number of different locations, villages and towns. And over a number of years, our colleague has been able to map the development or new developments within these areas. And for the context of the Gambia, this is becoming really important because it's allowing you to map community assets. It's allowing basically new infrastructure to be mapped and to be monitored. And with that, we can begin to monitor the rate of development in towns or in villages, but it will also inform such things as development and crises mapping as well. So OpenStreetMap and the ability to input information becomes quite key as us as users, but also for the wider community as well. And drawing on that example, there is something that's called crowdsourcing that has actually become quite popular in the sense of using volunteers, using crowds or the general public to increase our geospatial abilities. So one of the examples where crowdsourcing has been used is in Haiti. So in the 2010 earthquake in Haiti. And during this event, there was a lot of damage, but what we were able to do was report and map that damage because the cell towers and the mobile network was not affected by the earthquake itself. The information by reporting damage and requesting aid then allowed the response to be coordinated, aid to be distributed, and to really begin to plan the on-the-ground response before aid responders and NGOs were able to even reach the field. So the abilities of things like crowdsourcing is really quite important. And we've seen similar approaches being developed even in apps nowadays, where we've got something called MapSwipe, which is an app that you can download and contribute to. If we think about this in terms of its sense and its power of information, what we're actually doing is increasing through volunteers, through general public, we're increasing our ability to break down and analyse this information, to break down what we're doing. So that becomes quite key, particularly in the context of hazards and disasters, where information and real-time or near real-time information is quite critical to coordinating that response. From a more generalised perspective, we can also inform things like the land use and the land cover. The land cover is what is on the Earth's surface, and that informs our land use. So it's an urban area and it's being used maybe for industrial purposes. But what we can do, in very much the same way we can work out whether our vegetation is healthy or not, we can utilise information from imagery to say what is the cover of our Earth's surface. So we can map things like urban expansion and the change in land use, and we can map that over timescales to understand how quickly is that city, is that town expanding and developing. In the opposite sense, we can look at things like deforestation in the Amazon, or even something that's particularly interesting to me is understanding the impact of natural hazards. So are we seeing that the land use is changing after a natural hazard event? If we look at it from a social or human geography context, though, that's really important. The information on land cover and land use is key. It's going to inform planning. Where are we going to place the development of a new town, or where does a new school need to be built? It's going to inform policy decisions, and it's going to drive those spatial patterns and those spatial decisions that are really becoming the forefront of decision making, particularly from a UK perspective. Other types of information that we can collect then, this so far has been very much the information that we can see through visual interpretation and utilising that information. But what we can also do is collect information that perhaps is not as easy to interpret through satellite image interpretation or visual interpretation. So we can collect information on how hot or the land surface is, or how hot a feature is. So I mentioned before about the progression of wildfires and documenting areas of wildfires. But what we can do is also measure how hot that wildfire, or in this case, volcanic activity is. So we can gather long time series of data, thermal data. We can calculate that in relation to how hot is it, and get an equivalent measure of a plug socket. So what is the energy produced by that thermal feature? So the equivalent of energy out of a plug socket. To understand what's the behaviour of perhaps a volcano. With that, can we then identify that it has maybe a cyclicity in its data? So our example here is from Etna, and what we were discovering is at Etna is that at Mount Etna we were seeing almost an overturning, a renewal in activity around every 200 days or so. With that information, that we can understand changes in its behaviour, we can track changes in behaviour. Would we perhaps be able to identify triggers of volcanic activity? So going back into what Craig mentioned in terms of my research and my PhD, so does an earthquake have the ability to trigger volcanic activity? Or within this, can we even use this information to forecast future periods of volcanic activity? So thermal information or understanding long time series of data is really beginning to be quite critical in our understanding of our environment. And finally, then, our different one, I can imagine that this has been quite an information overload if you've not done GIS or remote sensing before. But a final way that we can begin to use remote sensing imagery, or in this case drone imagery, is to work out the elevation of our Earth's surface. So rather than looking or assuming that we're seeing a flat image and that we have no spatial component to that image, we can look or we can use UAV imagery, because it's got so high resolution data, and because we have a high overlap, to actually look at the elevation of an environment. So here we've got an example of a coastal wetland, and within that coastal wetland we wanted to monitor the change or the vegetation change within that area. But what we can see is gullies, and the fact that the gullies are actually lower than the wider wetland area itself. And the wetland itself is almost then encased by a higher feature. But what we can do, and what's key in terms of the drone itself, is something called structure for motion, or photogrammetry, is that high overlaps in our imagery allows us to work out what is the 3D structure. So we could apply that to the things like our volcano, and we could fly around a volcano and see the 3D cone and structure of a volcano, right through to cities and understanding the shape and the development of a city maybe, or even a building, and we could work out the 3D structure of a building. So this example in itself is geography, it's human geography, it's physical geography, but it could even extend into such things as construction and civil engineering, to looking at infrastructure and developments such as bridges, and even work out maybe if the integrity of a structure has been compromised. So on those points are really our geospatial technologies. As I said, it's quite an umbrella term, but they are quite broad and they're quite vast. What we're seeing is an increasing advancement in technology. We're seeing this move in everyday life to cloud and web-based computing. And we're seeing that advancement with geospatial technologies as well. But our information, our spatial information, temporal information, ability to increase our technology means that the amount of data that we're getting from geospatial technologies now is reaching or exceeding terabytes of data every day. And that means that we need to unlock that potential of the information. We need to unlock the technologies that are associated with that. So whether it is through agriculture, whether it's through crisis and disaster mapping, whether it's through construction, city planning, natural resource management, we have got so much potential in geospatial and location-based information that the technologies that are associated with that are coming together to increase and broaden our ability to understand the environment, the world in a different way, but also to make informed decisions, to make better decisions, and to uncover spatial information. So what I want to do, just to leave it there, is I'm quite aware that this is perhaps more of a newer concept to everyone than the perhaps other issues that you've been exploring in your webinars over the last few weeks. But if you are interested by this and you're wanting to learn and begin to understand more, there are a few resources that I think are things to get you started. The UK itself has set up a geospatial commission. The UK is promoting the use of geospatial data. It wants to increase how much we're using geospatial data in our everyday lives, both in local government, in public services, but how much us as consumers can use that information as well. So you can start to have a look at how the UK is driving that forward. We've got agencies such as NASA and ESA, the European Space Agency, and you can even see things like the image of the day, imagery that's been collected from one of their satellites, and how we can begin to use that information. If you haven't perhaps used Esri and ArcGIS before and you want to start even just having a look at it, there are freely available pieces of software that you can install directly onto your computer. Things as QGIS, and QGIS has a wide resource to get you guys started with looking at that information. So if you want to get started, those resources are there for you. And obviously, if there's anything that you want to know or you're interested in that I've said about today, do feel free to get in contact, and I can point you in the right direction, as this is probably an area you perhaps not explored as much as other areas. So hopefully you've got a better grasp from today of what we mean by geospatial and what we see in the developments of geospatial technologies. And I hope, as much as me, that you can see that the information we're gathering and the potential of this information is increasing, and we as individuals and as consumers are increasingly using geospatial technologies perhaps without even realizing that we're using it. So thank you very much.
That's fantastic, Charlie. Thank you ever so much for that. That's brilliant. Right, we've got a few questions. I'm just gonna pop to that. So you talked at the start, you mentioned Google Earth, and then, you know, as something that most people probably have used or come across, or Google Maps at least. And then obviously you mentioned QGIS at the end. So this person has asked, what's kind of the difference really between Google Earth? What does QGIS, for example, do that's so different to Google Earth?
Okay, so that is really key, actually. So Google Earth and Google Maps are their geographical information systems, but they have already been set up for you. You can run queries such as, how do I get from A to B with the quickest route, or where is the nearest petrol station to me? So all of that information and the applications behind that are already built into this software for you. Google Earth and Google Maps allows you to interrogate spatial information without actually doing much with that data. QGIS allows you to actually go that deeper level, a little bit further, to actually allow you to start doing that. So there are techniques, I won't name them because they'll probably just kind of confuse you a little bit too much there. But there are techniques where you as a consumer have gone, right, I want to know where to go from A to B, and Google tells that for you. QGIS allows you to work that out yourself. You can run applications, or you can what we call plugins and tools within the software that allows you to work that out and calculate it yourself without using software. So it could be that you, for your A levels, for your geography A level, want to produce a map that documents or presents the population of a town or a city. QGIS would allow you to download population data, to download that city and the space of how that appears as a city, and then present that data as a map. So it's very much more going to that next step about using that data and running those spatial queries yourself.
Thank you very much. And I think you know, from playing around with QGIS myself, I know there's quite a lot of webinars and stuff online, isn't there? There's a lot of support for it online because it's all open source. So it's really, it really is a fantastic tool to kind of have a bit of a play around with.
And interestingly, with the lockdown that's happened this year, we've made as a part of geography, we've made them move to QGIS for our students, and they've really enjoyed it, and really got on board with using it, and they've said how easy it is to use. And these are students that are using it for the first time as well. So the fact that they're finding it so easy to use, it shows that this open source nature and the availability of information is really useful. Yeah, definitely. So another question coming in. What do you think is the next big thing in geospatial technologies? Oh, that's a really hard one. I suppose it depends on where your interests lie. For me, my interests lie more in the remote sensing side of things. So how we can use satellite information, drones or aerial information to uncover information about our Earth's surface. There has been a particular push from the UK government to begin to use this data a little bit more. So as part of the European Space Agency that we were part of, we had satellite imagery that was being made available to us. And the UK government have been investing in making that what they call analysis ready. So it's ready to go, you can just download and use it. From the other perspective though, is spatial information and how we drive decision making. So if you were more of a decision maker, maybe a policy maker, a decision maker in local government, it's how you go about making those decisions. And that comes down to things, perhaps with looking towards the future, going back to the question about cloud computing or the access of information online through resources online, rather than having to download software, rather than having to have the skills and the capabilities of using this software. Is there a map that's available online that I can just say, right, I want to know this information, and that cloud system allows you to gather that information?
I think I tend to agree with that last point as well, that more public facing stuff. I know that there's been some work at other institutions. I think the University of Liverpool have done something on what I'm particularly interested in, looking at kind of using apps on your phone to monitor flow. It's not quite GIS, but it's using different technologies in a similar way. And I think, that leads on to kind of another question that's actually come in, which was, are there any tools that are so, quite nicely available? You mentioned a few different things, but kind of things that can be used during people's daily exercise, maybe to understand the landscape around them. Are there any tools that you know of that can be used for that?
So there are available pieces of software. It depends if your school has made it available to you, but we have ArcGIS and ArcGIS Online. You have things like Survey 123, where you can travel around in places, you can take pictures, and as you're taking pictures, you can associate the location to that information. More generally though, you can do things like that within Google Earth and within Google Maps. If you turn on which I have to admit I turn off because it becomes quite populous with the amount of pictures, but if you turned on the pictures in Google Earth, you can see people's locations and people's pictures. It depends on what you're trying to do, but there are things like, if you're, particularly at this moment in time when we're restricted on our movement and restricted to local environments of travel, there's something called All Trails, and All Trails allows you to map your walks, and it allows you to map kind of where you've been on a walk, but also associate pictures with that. So All Trails is quite good. I found it particularly useful in the last few months when I've been tiring of my daily walk and tiring of the same scenery, and I want to find somewhere else that's nearby that I can walk to. I've been using All Trails to understand where it is that other people travel to.
Perfect, thank you. So quite a topical one then. Is how might geospatial technologies help us get out of the coronavirus crisis? Over to you, Charlie.
Thanks, Craig. That is an interesting one, and I think if you look at the there's a American John Hopkins database that's actually mapping this from, well, actually at a global level. So it's collating information. John Hopkins is collating information at a global level to map where we're seeing coronavirus outbreaks. And where it is that we're seeing increases or changes in infection rates. So there is a real potential. And what I would say is that if you listen to perhaps the daily bulletins or the news briefs that we're seeing that information. The government, before we went obviously down into kind of our lockdown that we're in at the moment, we're making decisions based on tiers. And we were seeing that we were having localized lockdown, and that is based on spatial information. Where are the most cases occurring? Are they in a specific spatial location? Are we seeing a higher rate? what are the trends associated with that. Something else that perhaps is interesting based on the news that we've seen coming out over the last 24 hours is maybe whether we can map demographic data in relation to coronavirus cases to see if there is actually a pattern between certain demographics or certain areas being more or a higher risk of coronavirus.
Perfect, thank you. So taking out a bit more of the fundamentals, I suppose, of geospatial technology and geospatial analysis. This one just asks: is geospatial analysis different from map making, or are they essentially the same thing?
Oh, I've had this today actually with my students. I would say personally, your map making is your final step in a geospatial analysis. So your map is your presentation of the information, of the data. What you've got to do before you get to that point of having a map is analyze the data that sits behind it. So whether you've taken or downloaded data from census data that tells you the population of an area, until you actually take that into a GIS system, it doesn't just appear on its own. You have to tell it to appear, you have to tell it how to appear. You might want to see only a certain, like we've just talked about with the demographics of rate of coronavirus, you might only want to see a certain population of that data. You might have to filter that data. So all of those steps beforehand are your analysis, and your map is your final output. And I think actually there's a lot more work in the spatial analysis side of things. The map is important, the choice of colours, the choice of visualization that you present your data with, but it's the analysis of that data that becomes really important, because that's what holds the key to the decision making. So if you think of it from a policymaker or a government perspective, they often want a map, or they want some information that tells them where an issue is, or what the challenge is that they need to deal with. So it's that analysis before, and I think personally that's kind of almost the first thing that you do, and then you think about your map production.
Perfect. There's actually, if you've got a few more minutes, Joe, we've got a few more questions actually about the degree. So one of them actually asks kind of a general one. At the start we talked, it was mentioned obviously your course director for geography natural hazards. How does that differ from, the question asks, how does that differ from physical geography, from BSc geography? Okay,
so within our geography and natural hazards course, we actually have bespoke modules that are designed to focus on the natural hazard elements of physical geography. So you will do what we call common modules that are physical geography modules. Environments and understanding different environments, such as deserts, such as glacial environments. But as you progress through your degree, you almost become specialised with more of a focus on the hazard aspect. What I particularly like about our degree is that you have an element of choice. So I can kind of see these three threads coming through. So if you are particularly interested in understanding kind of the physical geography of why is that hazard occurring, why does that volcano erupt, why does a hurricane develop where it does, you're able to follow that thread and very much focus on physical geography, process space, and even bring in climate change here with how is that going to change in the future. What you've got then is another element where we've got the human geography and perhaps the disaster management element of natural hazards. So as Jade last week was talking about in terms of population growth, we need to consider these factors when we're looking at hazards. So as a hazard or a natural hazard occurs, it will affect a community or a region or a nation. And we need to understand how to respond to that and how to deal with those challenges. So there is the option with the degree to very much focus on that thread and that theme in terms of understanding how a natural hazard affects a community, how we can help make or facilitate the community becoming more resilient themselves, how we can put in place measures so that in the future they are less vulnerable to hazards, and how we can deal with those challenges, particularly within different contexts. So for example, if we went from the UK context to more of a kind of Indonesia or African context. So the degree itself has the physical geography elements and retains those physical geography elements, but it focuses more so on hazard aspects. And we have some really nice bespoke modules that actually me and Craig and Matt, who you would have already seen in our webinar series, that we lead on in terms of looking at geohazards, earthquakes and volcanoes, then into hydrometeorological hazards, so meteorology, pluvial flooding, right into coastal hazards. So there's a little bit of a kind of a bespoke difference, particularly when we get to third year, and thinking about how that in terms of is changing in terms of frequency and impact from the context of our changing environment through climate change, urbanisation, population growth as well.
Perfect. And someone's also asked about, there's a few questions about the degree actually. Someone's asked about field work. So what kind of field work do we do for the Geography Natural Hazards degree?
Okay, so Geography Natural Hazards, within our courses, we have elements of both residential field work and day field work. So obviously with our day field work, we do still stay closer to home. So UK-based field work examples such as the Peak District, even across to, as Matt, who you already had, very proud of this one, our extinct volcano in Dudley, but understanding and developing skills within geographical research. Then we have our international or residential and international field work. So our residential field work, we've got examples such as the Lake District and Norfolk, and then international field work, so Tenerife, which Craig leads at second year, and then at third year, which I lead, which is currently going to Sicily, to Mount Etna. I particularly like that one because it's almost the culmination of your degree and you get to go to the top of an active volcano.
Yeah, I feel like, I suppose I should add about the other degrees as well, just since it'd be unfair, I suppose, and as I'm course director for physical geography. So we on physical geography also go to the Lake District at the moment. These are all at the moment, they obviously could change. And we go to, as Charlie mentioned, I take them to Tenerife at the moment in second year, and then in final year they go to, at the moment, Morocco. And then the human geographers also again do the Lake District. That's a big trip in the first year. At the moment it's Berlin in the second year and the Gambia in final year. And these are all really heavily subsidised by the university, both various stages to quite a high level actually. So I suppose we should probably add that as well. Right, what else have we got?
If anybody does have specific questions on the course, do feel free to get in contact. Our email addresses, or my email address is at the start of these slides. So feel free to get in contact with any questions you do have.
Yeah, and I think we might put a bit more of a generic university and Coventry discussion on probably a later stage, I think,
yeah,
to talk more generally about it. So there's one last one just come in, which is back to being more general, and we can wrap it up there. It's quite a nice ending point. Obviously, you talked about the images on Google Earth earlier and different people's pictures. Should we be concerned about privacy with all of this?
That is a really good question. And I think something, particularly some people don't realise, is that on your phones, unless you turn it off, you're always actually releasing data from your phone. So as an example, your phone, regardless if you have Google Maps open or not, is always transmitting information, so we can know, where there's traffic, for example, on a road route. So there are ethical considerations to that information and the release of that information. What you can do in terms of this type of information, you can turn off your location-based services so that you aren't distributing your location. Within Google, that obviously in itself has some degree of kind of human-based kind of decision-making in there, in terms of loading up these images and making sure the images that you're making available are relevant to the site that you are making available. So what I would say is there are definitely ethical considerations, and in terms of the increasing use of spatial information through smartphones, it's something that we should all be aware of and think about what we're doing when we're using our phones or when we're using social media, and whether we're associating tweets and information to a spatial location. In the opposite sense, it does become very useful. We've had instances or examples. I'm drawing on one from Hurricane Sandy a few years ago, where actually locations of tweets was used to map the impact of the hurricane, and therefore distribute aid in very much the same way that Haiti was used, but this was used through crowdsourcing. In the Hurricane Sandy example, they used a hashtag of Sandy, and they were able to collate all of these tweets together and map out the distribution of where the impact was. So it has both benefits and potential ethical considerations.
That's perfect. Thank you very much, Charlie. So you've just had one, the final comment that's come in. Thank you so much, Charlie and the team. Another brilliant session. So that's lovely to hear, isn't it?
That's wonderful.
Yeah. So thank you so much, Charlie. It was fantastic. It was a really interesting insight into geospatial work and the work that you're doing. Thank you very much. I just need to add a bit of a thanks to Dr. Matt Blackett, running behind the scenes, sorting everything out again. Thank you very much for doing all the tech, Matt. Very much appreciated. And just a quick thanks to the RGS for obviously promoting everything and putting it on their website, and just an acknowledgement that they've got some fantastic other seminars that are available, so please check those out. And I've updated a list of new sessions, so as always, if any teachers are interested, please send me an email, craig.lashford@coventry.ac.uk. Charlie's put hers on previous slides as well, so if you want to go back and if you can send Charlie a quick email, she can add you to the list as well. But yeah, hopefully we're going to keep these running till after Easter now. But yeah, so we'll be back again next week at 3:30. We've got Dr. Dave McLaughlin talking next week, so look forward to seeing you. Thank you all again, and enjoy the rest of your week.